In this video, we shall be solving a question on maximum likelihood estimation. We have a question here, but for more of this, you need to subscribe to this channel. We are asked to find the MLE of this PDF. We find the MLE estimator of beta. I will also prove that the estimator of beta is unbiased. Solution. A. We are given this. For we to compute the maximum likelihood estimator of this distribution given, the first thing to do is to take the likelihood function. So the likelihood function of this is the product sum as I ranging from 1 to n, 1 all over beta exponential negative x all over beta. So this is the likelihood function. So if we take the sum product of this whole function, what do we get? We get something like the likelihood function f of x beta to be equal to 1 all over beta raised to the power of 1 exponential xi, because we are counting, multiplied by 1 all over beta 2 exponential xi all over beta multiplied by, it continues that way, and we get 1 all over beta raised to the power of n times, as this is going, exponential negative xi's all over b. If we write it out, we'll get our likelihood function to be 1 all over beta raised to the power of n exponential negative summation xi all over beta. So this is what we'll get. The next thing to do for maximum likelihood estimator is to take the log. But for we to take the log, we need to rearrange this so that it will be easier for we to take the log. So before we take the log, let's rearrange this. Rearranging it, our likelihood function will be equal to, we can write it as this, beta raised to the power of negative n exponential summation of xi all over beta. So this is what we get. The next thing to do is to take the log. Take the log. If we take the log, we say log f of x beta will be equal to, if we take the log of this function, we'll have negative n log beta. We take the log of an exponential. If we take the log of an exponential, we get that same function. So we get negative summation xi all over beta. So this is what we get. The next thing to do is to take the derivative and we differentiate with respect to beta, because that is what we are looking for. We are asked to find the MLE estimator of beta. So we differentiate with respect to beta. If we differentiate with respect to beta, we have something like this. Differential of log x beta all over the beta will be equal to, if we differentiate this, we get negative n all over beta minus, we'll now differentiate this. For me to differentiate this, we use what is called the quotient rule of differentiation. because a function is differentiating another function. So for we to differentiate this, we come here, we write it as summation of xi all over beta. We take this as our u, we take this as our v. And the formula for the quotient rule of differentiation says v du all over the beta minus u dv all over the beta all over v squared. So we substitute. First, we have summation of xi as our u and beta as our v. So here we put v, we bring down v. If we differentiate the u all over the beta, the u all over the beta, we get 0 minus, if we bring down u, our u is summation of xi, summation of xi. If we differentiate this function with respect to beta, we get 1. So have 1 all over beta squared, all over beta squared. So what we have will be equal to minus summation of xi all over beta squared. So that is what we put here. We have negative summation xi all over beta squared. We have succeeded in differentiating this. The next thing to do is to equate the whole of this to 0. We equate the whole of this to 0. So we come over to this side, come over to this side. Equating the whole of this to 0, we have negative n all over beta plus summation of xi all over beta squared is equal to 0. Because negative sign multiplying a negative sign will get a positive sign, which is this. So we can take this over to this place to give us negative n all over b beta is equal to negative summation xi all over beta squared. So this can cancel this. The next thing we do is cross multiply. Cross multiply. If we cross multiply, this will go here to give us beta squared all over beta to be equal to summation of xi all over n. Of course, this can cancel this. So we'll be left with beta to be equal to summation of xi all over n. If we watch at this is equal to mean. So it means that our beta estimate, which we are asked to look for, is equal to the sample mean. So we have succeeded in finding the estimate of beta. The next thing to do is to make sure that this is an unbiased estimator. We are asked to show or prove that this estimator is unbiased. We come over to this side. To show that this estimator is unbiased. Solution B. To prove that beta estimate is unbiased, we know that from what we got, our our beta estimate is equal to summation of xi all over n. So the expected value of beta is equal to summation of the expected value of xi all over n. If you sum a constant, you get n times that constant. N times that constant. So we have n expected value of xi all over n. Of course, this and this can go to give us our expected value of beta estimates to be xi, expected value of xi. We should recall that the expected value of xi is equal to our beta, which is this. So it means that the expected value of beta estimate, we need to show that it is equal to this. It will be equal to summation of xi is equal to summation of the expected value of xi all over n, which is also 1 all over n. If you sum this, you have multiply by n expected value of s, which is also equal to 1 all over n multiplied by n beta, because beta is equal to this. So of course this can cancel this. It then means that expected value of beta estimate is equal to beta, showing that the expected value of this is an unbiased estimator. So this is how we can show that the estimator is unbiased. For more of this, you need to subscribe to this channel.